सर आपकी वॉइस नहीं आ रही।
Am I audible now, class?
Yes, sir. Yes, sir.
Okay. So data structure module will start today. So before that, we'll have overview of data structures. So I have already told you it is logical and mathematical model of particular organization of data. Organization of data. File. So the data structure that we have to study, we can divide data structure into categories broadly. One is linear, one is non-linear. In linear, we have array, linked list, stack, queue. Okay, and here we have tree, graph, and hash table. So we'll study one by one what are the basic properties of these data structures, how to implement them using Python, and what are applications of all the data structures. So array, I hope you have already studied in C, and I have also discussed in class. So array is nothing but collection of similar type of element in C, but in Python we know that every collection is heterogeneous, so it can collect different type of elements also. It can have different type of elements also. So let us start. So first data structure, which is most students feel complicated to implement, that is linked list. So I will start with linked list first. Okay. Now, whenever we talk about linked list, what is a linked list? Linked list is linear list. It is a linear list stored in non-contiguous location. So non-contiguous location means unlike array, like this is the array. You have all seen it. So 0, 1, 2, 3, 4, 5, 6. So if we have, address of this element means if I know A0, then I can have A1, then A2, then A3. So just by incrementing the location, we are able to access the next element. It means that they are stored in contiguous location, one by one. They are stored one by one. So just by having address of first element, you can access all the elements. Fine? Just by incrementing it. So it is an incremental approach. This is array. Fine? Now in linked list, what happens? In linked list, it may happen like suppose you have to store 5, for example, marks of 5 students. You have to store marks of 5 students. So one arrangement is that I will create an array. And I will store the marks. And other arrangement is that this is an array. Okay. Other arrangement is that I will put 1 marks here in the memory. Suppose this is your memory. 1 marks is here. 1 marks is here. Then we have here. Then we have here. And we'll connect first with the second. Okay. Second with the third. Third with fourth. And fourth with fifth. And we'll use a special pointer called head or start, which will tell you where the linked list starts. So this is a linked list. This is a linked list. So every elements are linked with each other. Every elements are linked with each other. Okay. Just wait for us. So this is called a linked list. So in general, if you see in general, so this complete This complete structure is called a node. Is called a node. In its simplest form, it has two parts. One part is the information part, other part is the address part. Other part is address of next node. So this structure is called a node, info part and address of next node. And this is how linked list look like. Now, what is the difference? Here, suppose if we are switching to C for some time, we are taking an integer array and we are assuming that integer is of 2 bytes. Then if this address of 0th element, if address of 0th element is 1000, then address of first element will be 1002, address of third element will be 1004, then fourth element will be 1006, and address of fifth element will be 1008. Just by incrementing locations we got the address. But here, suppose if this is 1001, then maybe it is 5015, maybe it is 7016, maybe it is 2023, maybe it is 1009. So here by incrementing you cannot get the next location. Here you have to follow the link. You have to follow the link. So therefore, every element which is called a node contains an information part and it contains address of the next node also. So where we will find the next element? This is being contained in the node itself, where we are going to find the next element. This is called this structure is called linked list. Is this clear, class?
Yes, sir.
Okay.
Yes, sir.
So now logically, like in Python, we know that every collection is growable, like array is implemented by list, and we know that list is growable. There is no fixed size. But logically, what we say that array is fixed in size. Like in C programming, you declare like A5, and linked list is growable. But in Python, everything is growable. Okay. So we talk about this linked list with perspective of Python also, but before that, I will tell you with perspective of C. So if we are talking about C language, then we say that this is a static implementation. Why? We have to give the size beforehand, and this is dynamic allocation. It means it can grow and shrink. In C language, if you have declared the size of array as 5, it cannot be reduced. Okay, it is 5 throughout the program. But here, linked list can grow also, linked list can shrink also. So just understand that linked list is a collection of node. And what is a node? Node is a structure which has two parts in which it contains information part, and other it contains address of the next node. All the nodes of a linked list are scattered over the memory and they are connected via link, okay, or address. So first node is connected to second, second to third, third to fourth, and so on. And we have a special pointer called head or start, which point to the start of the linked list. Sometimes we also have a special pointer called tail or end, which points to the last node of the linked list, which points to the last node of the linked list. And last address of last node contains null. Address part of the last node contains null. Is it clear, class?
Yes, sir.
Okay. So what we have summarized, let's see. So linked list is collection of nodes stored in non-contiguous memory allocation. Memory allocation. First point. Okay. Second, a node is divided in two parts. First, information part. Second, address of next node. Like this. Info and address. Third, every node contains address of next node. Okay, every node contains address of next node. That is, first node contains address of second node. Second contains address of third node, and so on. Fourth, address part of last node contains null, or in Python we have none. Okay, in C we have null, in Python we have none. So I'm writing none here. Contains none. It means nothing. Fifth, special pointers head, oblique start, and tail, oblique end are used to point first and last node of the linked list respectively. So I hope I have summarized all the points. Just go
Sir,
through it
can you
quickly.
repeat fifth point, sir?
Yeah. Yeah.
Sir, can you repeat fifth point?
The special pointers head oblique start and tail oblique end are used to point first and last node of the linked list respectively. Hope it is clear.
Yes, sir.
So you got an overview of linked list.
Sir,
Okay. Yeah.
so what is the meaning of non-contiguous?
Non-contiguous. Non-contiguous means which is not continuous. It
Okay.
is not continuous. It is not one by one. Okay. Like for example, suppose MCA A is sitting in L12 and MCA B is sitting in L11. So they are contiguous. But suppose MCA A is sitting in L12 and MCA B is sitting in K12. This is non-contiguous.
Okay, sir. Their address location are not in a
Yeah,
continuous order.
just understand that if we have a contiguous location, then
Hmm.
just by incrementing you can point to the next element.
Yes, sir.
Okay, and if we have non-contiguous locations, then by incrementing you will not get that. It is not definite that you will get the next element. Is it clear?
Yes, sir.
Okay, fine. So I hope this is clear to all of you.
Yes, sir.
Okay. Just a minute in between. Chitrans, you are here. Man Chitrans is here. Okay, maybe
Yes, sir.
Okay. So I think your answer is correct, Chitrans. Okay. You are in hostel or out of station?
सर घर आए थे लेकिन वापस आएंगे शायद.
Okay, so maybe after the class on Zoom I will tell you. I think your option A is correct. Okay.
Okay, sir.
Yeah. Fine. So let's move to the operations on linked list. So before moving to operations of linked list, I will tell you what are several variations of linked list. Okay, or we can say types. Logically, what are different types of linked list? So first is this one that I have shown you just now. We have an info part. This is head. Okay, suppose it is stored here 9, then suppose 10, then suppose 0, and it is containing null or none, whatever. This is called single linked list. Okay, then we have one more variation, head. We'll discuss each of them in detail, but just for your, tail. This is called double-ended linked list. Double-ended or doubly linked list. Okay. Now in single linked list, In single linked list, every node node contains address of next node only. Next node only. It means, what does it mean? It means only forward traversal is possible. Okay, you can only move forward. यहाँ से यहाँ आ सकते हो, यहाँ से यहाँ आ सकते हो, only this. Only forward traversal is possible. Okay, and address of last node is equal to none. Address of last node is equal to none. Is this clear? Now, in double-ended linked list, what happens? In double-ended linked list, every node contains address of both previous and next node. Previous and next node. Okay, what is the meaning of this? Both forward and backward traversal is possible. As you can see here, this node is containing address of this node, and this node is also containing address of this node. So this node is containing address of this node, and this node is also containing address of this node. So in a double-ended linked list, node look like this. We have an info part. We have previous address, node address of previous node. We have address of next node, and previous address of first node and next address of last node are none or null. So previous is null, last is null. Why? Because पहले नोड से पहले कुछ नहीं होगा, last नोड के बाद कुछ नहीं होगा. Therefore, previous of the first and next of the last will always be null or none. Nikhil, you wanted to ask something?
Yes, sir.
Yeah.
Sir, traversal का meaning एक बार बता दीजिए. Traversal का meaning.
Traversal means you are visiting every node at least once, exactly once. आपने इस नोड को विजिट किया, फिर इसको विजिट किया, फिर इसको विजिट किया. It means like if you are told to take a round of complete college. Okay? तो आप एक कॉलेज का राउंड ले रहे हो, आप एक एक जगह से एक एक बार होके गुजर रहे हो. This is called traversal. Is it clear?
Okay, sir.
So I hope it is clear. The students, single linked list and double-ended linked list, what is the difference? Yes?
Yes, sir.
Yes, sir.
Okay. Now we have another category of linked list. This is single and double-ended linked list. Now we have something which is called circular linked list. Okay. Again we have circular single linked list, and we have circular double linked list, doubly linked list basically. So in circular linked list, circular single linked list, next pointer of the last node is not null. Instead, it points to the first node. Some info is here. So if you see next pointer of last node is not null, it is pointing to the first node. Okay, next pointer of last node is not null, it is pointing to the first node. So this is circular single ended linked list. And then circular double ended linked list, what happens? See. So next pointer of last node points to the first node, and previous pointer of first node points to the next node, last node. This is head. This is tail. So Now in double-ended linked list, what I told you, that previous pointer of first node is null. Here it is not null. It is pointing to the last node. And next pointer of last node is null. Here also it is not null. It is pointing to the first node. So previous pointer of first node will point to the last node, and next pointer of last node will point to the first node. This is circular double-ended linked list. Okay. So I hope types are clear. Types of linked list is clear, class?
Sir, explain this once again, sir. This single linked list and double linked list. So because in single linked list of circular, it is also pointing to the start, and in this double also it is pointing to the last.
In double-ended linked list, no, it is not single and double. It is circular single.
Yes, sir. Sir,
Single
that is
linked list
clear.
is C. Single linked list is just like that, just like this.
So the last singly linked list is pointing to the head.
In double-ended linked list, C. First C here, that figure that I'm drawing here. See this. Sir. This is simple double-ended linked list. Clear?
Yes, sir.
Now here, previous pointer of the first node is null. Okay, double-ended linked list. What is double-ended linked list? Where every node points to previous node also and next node also. So before first node there is nothing. So previous pointer of first node is null and next pointer of last node is null. This is simple double-ended linked list. When I will make it circular, then this previous pointer will point to the last node. And this last pointer, next of last node, next pointer of last node will point to the first node. Is it clear now?
Yes, sir.
Sir, this is also same, and that circular linked list is also sort of same, sir.
No, it
What
is
is the
not same. It is not same. Operations will change. I will tell you. I will tell you.
Okay.
Similarly, this is single-ended linked list. So here next of last node is null. When I will make it circular, it will not remain null. It will point to the which node? First node. Okay. So operations will change. I will tell you where it will change, but some operations will change. I hope it is clear, class.
Yes, sir.
Okay. Have you studied structure in C language? Is the structure completed or not?
No, sir,
No,
not
sir.
yet.
No, sir.
No,
Not yet.
sir.
No, sir.
Not
It is
even
not yet
pointers.
started also.
Yes, sir. Not even pointers.
The pointers are also not completed. Okay. Okay, fine. So let's continue with Python also. I thought in C it would be easy to explain the concept, but let's check with Python. So we'll start one by one. Now see, first we'll talk about node. I am taking the simplest form. Okay. A node which is having only two parts. We have an info part. We have a next part. Now we'll call it next part. Okay, we'll call it data part. Data and next. So data is the information stored and next is the address of next node. Okay. Data is what? It is information that you want to store 1, 2, 3, 4, anything or marks of the student. Information is stored. And next is address of next node. So this is a node. So tell me what operations are possible on a node. अगर एक नोड है तो उस पे क्या क्या ऑपरेशन हो सकते हैं, क्या क्या हम जानना चाहेंगे, what information you want to extract from this node? Anyone?
The information in the head data and information in the next head data.
Just a minute. Just a minute. Okay. So first of all, what we'll need a constructor. Okay, that will initialize, and we'll need to know what is the data stored. Let's write it one by one. So first we require a constructor, then information about two things: data, which is stored, and address, that is next. Third, modify data. Fourth, you can set the address or change the address. Okay, so these are common functions which we can apply on a node. Okay.
Sorting also.
Hmm?
Sorting.
Sorting.
Yes, sir.
Sorting is applied on linked list, not on node. Node is a single entity. Remember this.
Okay, sir.
Okay. So these are the functions which we can apply it on a node. Okay. So now I'm creating a linked list. Or let's say, so first of all, remember that a linked list is nothing. A linked list is nothing if there is no head. अगर head नहीं है आपका, तो start pointer ही नहीं है, तो linked list कुछ नहीं है. Or we can say it, a linked list is accessed using head or start pointer. Okay, using head or start pointer. So suppose if a linked list does not exist. Okay, what I'm saying, if a linked list does not exist, then what will be the value of head class?
So none.
It will be none in Python and null in C. Okay, I will talk about Python also, don't get confused. If linked list is empty, then head is none. Okay, so now we'll try to implement the single-ended linked list. Now we'll try to implement the single-ended linked list. So just see. Operations on single-ended linked list. So suppose linked list is existing. And we are using both pointers for our convenience. Okay. Now we have a add operation first or insert operation. Okay. So in this category, we have three types of additions. First is add at the beginning, add at end, and third is add after. Add at beginning means that every node will become the first node. Okay, when whatever node I will add at, that will become the first node. Add at the end means whatever node I will add will become the last node. Add after means suppose I want to add after 0. It means I have to add between these two nodes. Is this clear? These three operations, class.
Yes,
Yes,
Add
sir.
at beginning, add at end, and add after. Clear? Now let's explore one by one each of these operations. So first I am going to explore add at beginning. And I will use pseudocode for this. Okay. No syntax relevant to any language. So first operation, before using any of these operations, you have to create a node. क्या करना पड़ेगा आपको? Node create करना पड़ेगा. Okay. Then what you have to do? You have to insert information in node, and then you have to add the node at given position. ठीक है? So what I want to do, I want to add 20 at beginning of list. Okay. So first of all, I will create a node which will contain 20. Okay. And next part will be none. Why? Because when you will create node, there is no next node. So next part will be none. And this is our existing linked list. Okay. And this is my new node. Suppose this new node is named as P. I have created a new node P. Okay. Now what I have to do, I have created a node. This is my existing linked list. I have to connect this node to this. I have to connect this node to this. So what I will do, I will write P dot next is equal to head. Okay. So what I have written, P dot next is equal to head. So when you will write this, what will happen? This next, which was null, it will start pointing to this. P dot next is equal to head. Then what I will write? I will write head is equal to P. So after this, what will happen? This head pointer will start pointing to P. After this, the head pointer will start pointing to P. And finally, what we'll get? We'll get 20, 9, 6, 0, 11, tail, and head. Is this clear, class?
Yes, sir.
Is it clear?
Yes, sir.
Yes, sir.
Okay. So this is the case when linked list exists. Now suppose linked list does not exist. So if linked list does not exist, then head is equal to tail is equal to none. So now you will create a node, say P, mute yourself. You have created a node P, and since linked list does not exist, this is the first node and this is the last node. So what you will simply write? Head is equal to tail is equal to P. Head is equal to tail is equal to P. Is this clear?
Yes, sir.
Fine. So if linked list does not exist, the node you inserted is the first node itself, it is the last node itself. It means if there is a single node in a linked list, it is first node also, it is last node also. So head and tail both will point to that particular node only. I hope this is clear to all of you.
Yes, sir.
So let's quickly see the salt implementation of the concept that we have studied till now. Okay, let's see the implementation. Let me just share my screen. Is the screen visible?
Yes, sir.
Yes, sir.
Okay. So first of all, what we need to implement a class node. Okay. So first we will need a constructor. Let's create with none. So I'm taking it as a private variable. You can take it public also. Private I'm taking because logically it is part of linked list. So it can be accessed using public functions only. Okay. So initially both is none. We have no data and we have no address part. Okay. Then we need to insert a data. So I will write def set data function. Is equal to data. Next we have to set address. Is equal to next node. Okay. And then we need to view the data and address. So let the get function. And I need to view the address also. Okay. So what I have created just a node class. I have created a node class right now. Okay. Now I have to create the linked list class. We are implementing single linked list. Again, constructor. So initially linked list will be empty. So what I will do, I will take head pointer, I will take tail pointer, and both I will set to null. Okay. I have to set this head and tail. To set head. To new node, suppose. Then set tail. Some node. Then I have to get also the values. Let me copy this. It will be now get head. It will be would return self dot underscore underscore head. It will be would return self dot underscore underscore tail. Okay. Now most important thing that we need is adding. So add beginning, suppose. So first what I have to do, I have to create a node. So first I will create a node. So let P is equal to node class constructor. Okay. After creating a node, I have to insert data. So I will call set data function of P. Here I will pass data that I have to insert. Then I have to, what I have to do, I have to check whether linked list is present or not. Linked list is present or not. So if self dot underscore underscore head is equal to none. Okay. So if self dot head is equal to none, then what will happen? This will become first node itself. Self dot underscore underscore head is equal to self dot underscore underscore tail is equal to P. So since it is the only node in the linked list, so head and tail both are pointing to this node P. Okay, else. So if linked list exists, then what we have to do? We have to set the next of P to the head. So what I will write, P dot set next. Here what I will write, self dot underscore underscore head, and self dot underscore underscore head is equal to C. Okay. So I've created a node. I've inserted data into the node. Next was already none of the node class. Then we checked whether linked list exists or not. So if set dot head is equal to none, it means linked list does not exist. So if linked list does not exist, then head is equal to tail is equal to P. Else, what we'll do? P next will point to head. P next will point to head, and head will point to P. Now we'll write a function for traversal. Okay. We'll take a temporary pointer temp is equal to serve dot underscore underscore head. So temp will point to head, first node of the linked list. Then what do we have to do? We have to check whether the linked list exists for traversal also. If temp is none. Okay. If temp is none. So if temp is none, what will write? Print linked list doesn't exist. Okay. Otherwise, while temp is not none, print temp dot get data, and temp is equal to temp dot get next. Okay. Now let's create an object first of the single linked list. Say s is equal to single linked list, and then I will call s dot traverse simple. So see, it is printing linked list does not exist because I have not added anything. I will explain the code later, but see here, linked list does not exist because I have not added anything yet. Okay. Then I'm adding say one element. Suppose 6 I'm adding. Okay, what is add beginning? And traverse s dot traverse. So now it is printing 6. Again, I'm adding one element s dot Add beginning. Suppose 7 I am adding. And again I am calling traverse function s dot traverse. So 7 and 6. Run configuration per file. Now it will be clear. Okay, so x dot traverse here it was 6, now 7. Let me remove this. So 2 elements I have added. So it is printing 7 and 6. Why 7 first? Because we are adding at beginning. So see this code. I will starting from here again. This is the node class. So as I have told you, okay, I will copy the code and then I will tell you. Just wait. I hope this code is visible to all of you, class.
Yes, sir.
Okay. Now let's see. So first what I have done, I have just created a node class as I have told you. So in the node class, see what this node class does. Just wait, I am telling you. Okay, so what node class will do? It will just create a node. Okay, so what it will do, it will create a node and info will also contain none, address will also contain none initially. And it supports function set data where we can insert element here, set next where we can assign address here, get data where we can view this data, get next where
हेलो
we can,
सर
yeah,
सर ये आपने सेट डेट करा है उसको शायद आई थिंक
set. अरे स्पेलिंग गलत हो गया यार, स्पेलिंग पर आ जाओ, कंसेप्ट समझो, वही कर देता, तुमने टोकी दिया है तो डेट नहीं, डेटा है, डेटा। यहाँ भी सही कर देता हूँ, ये तो इमेज। चलो लेट अंडरस्टैंड द डेटा। ओके, सो किसने किसने इसको डेट समझा है? हैज एनीवन अंडरस्टूड इट एज अ डेट एक्सेप्ट दिस पर्सन? क्लास, we are not setting date, it is clear?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Now see. So set data, get data, set next, get next. I hope it is clear what we have done. This class is doing this. We create a node with none, and it is supporting these functions. Now this node will be used by linked list class. Class single linked list. Now what this class will do? First of all, its constructor will initialize two pointers, head is equal to tail is equal to none. इसका मतलब है empty linked list. When we are starting the program, we don't have any linked list. It is empty linked list. Then again, we want to set value of head. This C set head. We want to set value of tail. Set tail. Now, why I'm saying these pointers, although there are no pointers in in Python, but I'm saying it pointer because both are containing addresses. They will contain address. They will point to some node in the memory. So this is set head. I will have a function. It will, it will make head to point to a particular node. Set tail. It will make tail to point to a particular node. Get head. It will give me the information to which node head is pointing. Get tail. It will give me the information to which node tail is pointing. And then add beginning. What it will do? It will add an information at the beginning of the linked list if linked list exists, and if it does not exist, then this node will itself become the first node and last node. So if it does not exist, see this code. If self dot head is equal to none, it means linked list does not exist. This code. So if self dot head is equal to none, it means linked list does not exist. So if linked list does not exist, then this node that we have created with some data 20 is itself the head node also, is itself the tail node also, because it is the only node which you have created right now. So both head and tail will point to the newly created node P. Is this clear? Till here it is clear, class?
Yes, sir.
And if linked list exists, suppose this is the linked list which exists. So tail is pointing to last node, head is pointing to first node. This is the node that I have created. So this node, since I have created, linked list is existing. So P dot set next is equal to self head. So what set next function is doing? Set next function is forcing the next part of the node to point to some node. Okay, see this. Set next function is forcing the next part of the node to point to some node. So this some node in case here is head. So P dot set next will point to self dot head. P dot set next will point to self dot head. It is pointing here. And then finally, since now it has become the first node because we have added at beginning, so head is equal to P. So see, self dot head is equal to P. So now this head from here will come here. Is this clear, class?
Yes, sir.
Okay. Now see the traverse function. See the traverse function. So for traversing this linked list, we need a temporary pointer. Okay, for traversing this linked list, we need a temporary pointer. So I've taken a pointer temp. So see here, temp is pointing to self dot head. It means temp is also pointing to the first node, head is also pointing to the first node. Because you cannot move head pointer. If you will move the head pointer, reference of linked list will be lost. So always for traversing, we need a temporary pointer. We have taken a temporary pointer. Now again, before starting traversing, I will check whether linked list exists or not. So if linked list does not exist, I will simply print linked list does not exist. So therefore, I have checked it. If temp is none, okay, if temp is none, linked list does not exist. So this condition is false in this case because linked list is existing. So when linked list is existing, till temp will not equal to none, we'll keep on traversing. Till temp is not equal to none, we'll keep on traversing. What we'll do? We'll print this data. So what I am printing, I print temp dot get data. So what this function will do? This will return data of node to which temp is pointing. Okay. So temp is pointing to first node. So it will return say 20. Suppose it is 0, it is 1, it is 19. So it returns 20. Then temp is equal to temp dot get next. So what I am doing, temp is equal to temp dot get next. So what get next function is doing? Get next function is returning address of next node. So temp is equal to address of next node. It means temp from here now went to here. Now again it will print temp dot get data. It printed 0. Then again temp went from here to here. Then again it will print 1. Again it went here from here. Again, it will print 19. Again, it went here from here. So when it came here, it became none. So when temp became none, we exit. So output what we got is 20, 0, 119. In this case, 7 and 6 because we are adding at beginning to 7 and 6. So is this clear, class? Any confusion?
No, sir.
I hope single linked list add at the beginning is clear to everyone. Yes? Shall we move to the next topic? Add at the end.
Yes, sir.
So now we are going to see single linked list operation add at end. Okay. So obviously, if linked list does not exist, then head is equal to tail is equal to whatever new node you have created. Okay. But if linked list exists, okay, then what you have to do? You have to create node again, insert data again, and add node to appropriate position. So suppose I have created a node P with information, say 20. Now tell me what should I write to add this node to this linked list at the end? What should I write? Tail तो क्या होगा tail dot next is equal to p
P.
and tail is equal to
Tail dot data, p dot data.
okay. Or in terms of code, if I say, so suppose this linked list is s, suppose, just wait for a second, we got a call. Let me copy that code also here, then it will be clear. Just wait. See this code. S is the object that I have created. This S is the object I have created. Okay. So I will write S dot, which function I am going to call? I am going to call set tail. This function. This function. S dot set tail. So set dot tail is equal to new node. So this is my new node. So I will pass P here, for example. S dot set tail P. So what will it do? This operation will do this. Sorry, not this. This I will not do. First I will call, because tail is a node, tail is pointing to a node. So I will call tail dot set next is equal to, here P I will pass, this one. This, see. This function I am calling. Why I am calling node class function? Because tail is nothing but a node. It is pointing to a node. So set next will set the next of the tail. So next of tail is this. When I will call tail dot set next to P, it will set this pointer to P. It will start pointing here. So once this has been done, then what I will call? I will call this object, single linked list object dot set tail, because I have to shift tail from here to here. I have to shift tail from here to here. Now I will call s dot set tail P. So after this operation, from here this tail will be gone and it will come here. Is it clear, class? Or in pseudocode, what we can write? We can write that tail next is equal to P and then tail is equal to P. See here once again. So this is tail. This is my new node P. So what I am writing, tail next is equal to P. So tail next means this. So when this is equal to P, it will start pointing here and finally tail is equal to P. So tail is equal to P. Now this will become tail. Is this clear, class?
Yes, sir.
Yes, sir. Okay, so let's code this add at the end also quickly. So add at beginning I have done. Now we are coding add at the end. Okay, so some of the code is same. I have to create a node, I have to set data, I have to check whether it is empty or not. So I will copy this code and I will modify the else part. P is the node I have created. Okay. This I have to- Okay. Okay, let's see. Send data. Okay, so 6 and 7. So see, 7 has been added at the big end. 7 is added at the end. Again, you will call this dot end. 9, for example. So 9 will go at the end. Traversal I am not calling. Because 7 के बाद सीधे क्या ऐड हो गया 9 हो गया something is missing. Just wait. Set dot underscore tail is equal to next dot p. Add end is 7. And after 7, I am adding 9. 6 and I added 7. So set tail is equal to p. Just let me correct it. Somewhere it is creating the problem. Serve dot tail dot set next is equal to p. And see if I write like this, self dot underscore underscore dot is equal to P. Okay, 6, 7, 9. So something is, see, with this function set tail. Where is set tail? Set dot underscore underscore tail is equal to new node.
सर वो सेट टेल फंक्शन 2 बार लिखा हुआ है, गेट टेल होना चाहिए एक बार।
कहाँ पे?
लाइन नंबर 23।
Set. Okay. Okay. So it can work like this also, but let me try again the set tail function. It should work. It should work. Okay, fine, working. Okay, so I hope it is clear, class. At the end, is it clear to all?
Yes, sir.
Okay, I will share this code also, so you can go through this code also. Fine, at home. So single linked list, 2 functions we have done: addition from the beginning and addition at the beginning, addition at the end. Now, before studying addition after, we'll see deletion from beginning and deletion from end. Okay, then we'll see the add after. Because in add after there are 2 cases. So I will discuss that later. Today I think it can be completed in next 15 minutes. Or say let us try. Let's go with add after only. So now in single linked list, we are going to study add after. Okay. Suppose a linked list is given, obviously linked list will be existing, then only you can add something after. Fine. Suppose I want to insert x is equal to 6 after y is equal to 12. Okay. So now this insert operation has 2 operations basically. First is search. You have to search for y, whether it exists in linked list or not. If it exists, then only you can insert. And then we have to add item. So when we are talking about search, we'll implement linear search on linked list. We are going to implement linear search or linked list. Okay. So for addition, what should search return? If I'm I want to add after any element, and I'm searching for a data in this linked list. Suppose I'm searching for 12. So linked list must return address of this node. This node linked list will return. So suppose this linked list node is called P. Suppose name of this node is P. So linked list must return P after search operation. It returns P. Then only you can insert an item here. Now, after it has returned P, there are 3 cases. First case is, it is the only node in the linked list, or 2 cases are there basically, not 3 cases. First case is that it is the last node. Okay, and it is somewhere in linked list, or it is not the last node, the right word. Okay, although I'm just telling you for your comfort, these two cases were implemented in the same way. But suppose it is the last node, so insert after will call insert at end. If it is the last node and insert after means what? Insert at end. Suppose I want to insert after 20. So since 20 is the last node, I will insert here. So by default, what I am doing? I am doing insert at end. Is this clear, class? Is it clear?
Yes, sir.
Okay. So now, and if it is somewhere else, like suppose if 0 I am searching, then I have to do some adjustment. Like I have this node, then I have to do some adjustment. So let's see in detail. I think I will explain the operation today, and coding we can do only tomorrow. Let's see. So suppose this is the linked list 9, -1, 12, 13, 20, head. Now I have to insert after y is equal to 12. For example, I have to insert x is equal to 90. Okay. So again, first create node, then insert info in node, and then add node to proper position. Add node to proper position. Okay. So what I will do, I will create a node P with information X. Node name is X, suppose. And this is Y. Okay. This. So first I have to reach till here. I have to reach till here. So how I will reach till here? So I have to search. Okay. I have to search here. So for searching, I have to implement the search algorithm. So how I will search? First case is that. How I will search? So let's see. So for searching, I have to traverse. So I will take a temporary pointer, temp. So temp is equal to head. Then what I will do, I have to search for y. I have to search for while. So what I will check? If while temp not is not none. Look again, pseudocode, nothing to do with programming syntax. So if temp dot get data, so I will check data of temp is equal to y. Okay. Then what will return? Return temp and break. So if we got data, then we return temp and break. Okay. Else temp is equal to temp dot get next. Okay. So let's understand this code, what this code is doing. So this temp I am taking, then I am checking whether temp data is equal to y. So here 20, y is x is y is 12. So what I will compare? I will compare 12 with 20. Condition is false. So temp dot get next. It means temp will jump here. Now again I will compare 12 with 13. Again false. Temp will jump here. Again I will compare 12 with 12. So I found the data. So I will return temp and break. Is this clear, class? So first node data compared, not matched, temp forwarded, again data compared, not matched, temp forwarded, again data compared, match. So we'll break here and we'll return the temp. Is this clear? Yes or
Yes,
no?
sir.
Search
Yes, sir.
operation is clear? Okay.
Yes, sir. Yes, sir.
So once you have found temp, then you have to insert this node P after temp. Okay. So this pointer will now point here, and this pointer will now point here. Okay. So what we will do, you have to do for inserting P. For inserting P, what will happen? This pointer will now point to P, and P next will point to this node. This you have to do. So how we will write this code? So you have got temp. So temp dot, sorry, P dot set next. P dot set next is equal to, so this pointer has to point here. What is the name of this node? Class, this node is name is temp. What is the name of this node? Anyone? ये नोड क्या है? टेम्प का नेक्स्ट नोड है ना क्लास. What is the name of this node? This is next node of the temp. Yeah, good. Winner Pratap, temp dot next. And if we go according to code, we'll call it temp dot get next. क्योंकि get next ही हमें next node का address दे रहा है. So this function will return this node. So set next is equal to temp dot get next. So ये pointer अब यहाँ point करने का. Okay, and then we have to set this pointer. So I will call temp dot set next is equal to P. तो ये pointer अब यहाँ point करने का. Is this clear, class?
Yes, sir.
Okay. तो ये simple case है when you will found the data. And if you do not find the data, it means that after this while loop, if temp is none, then it means data is not found. Okay, temp is none, it means data is not found. I hope it is clear now. Search operation and insert operation. Okay, so let's make a search function first. Let's make a search function which will return you the address of the node where this is found. Let's make a search function. So again, I am going to add search function. Search the data. Okay, so if search dot underscore head is equal to none, it means linked list does not exist, so we can't search anything. Print no linked list, else temp is equal to self dot underscore head. Okay. Easy. Yes. While temp is not none. Fine. While temp is not none. If temp dot get data is equal to data. Return temp and break. Okay. Else temp is equal to temp dot get next. Okay. And if this while loop continues, it means data is not found. So return none. Okay, so let's see whether we can search or not. So with 9 I want to search. So see, I'm getting this 9. It means it exists. Okay, because I knew that 9 exists. And if I'm just printing s dot search, so I'm getting this temp also. This temp object I'm getting. Okay. So if data exists, it will return temp, otherwise it will return none. Now I will write the function add after. Suppose y is equal to input enter after with the data to add. For example, print input. Okay, now I will call the search function. So I will create temp is equal to self dot search data y. Temp is none, print word insertion, else what else we have to write the code. So we'll create a node. Suppose p is equal to node and p dot set data set हो गया, then p dot set next में हमने डाल दिया temp dot get next and temp dot get next ये p. Okay, so p dot set data में data, p dot set next is equal to temp dot get next, the same code that we have written there, and temp dot get next is equal to p. I hope it is done. Let's see. So s dot add after, so first value is 6, 7 after 7 I want to add 10. Suppose let's run the code. So move this. Node has no attribute set data. Node is having attribute set data. What is the capital D, sorry. Capital D, capital D, capital D, capital D, capital D. So 10 is not found actually. After 7. Now what happened? Get next, take one positional argument. Where is get next? temp dot set next. Someone mic is unmuted. Please mute it. So see, it is being added after 10, after 7. Okay, 10 is added here. Now let's check for once more. So after 9 also it is added. Add after. Okay, the same code I have written here. See, p dot set next is p dot set next in bracket temp dot get next. The same code was here also. See this. Same code is here also. Just it is pseudocode, that's why I put equal to, otherwise it will go into bracket. And temp dot set next is equal to p. So same thing I have written here also. So temp dot set next, I passed p here. Is this clear, class?
Yes, sir.
Yes.
So I think today's class was quite hectic, but you can imagine that, we have only seen the add operation in 100 minutes of linked list. But tomorrow we'll do the delete operation. So I will share this code today itself. Please go through the complete code, type the code, do not copy it, type the code and run on your console. Okay, and try implementing the logic of delete from beginning and delete at end. At least try. Is it clear?
Yes, sir.
Yes, sir.
Okay, sir.
Yes, sir.